This lesson is about multiplying improper fractions by fractions. Okay, so before we begin solving any problems, let's just do a little review of our vocabulary. So we know when a fraction has a numerator that is less than the denominator, this is called a proper fraction. And these numbers occur on the number line between 0 and 1. So our proper fractions occur between 0 and 1. 3/4, 2/3, 1/8, 3/16. Okay, those numbers are all less than 1, so they come between 0 and 1 on the number line. Now, fractions that have a numerator that is greater than the denominator, we call these improper fractions, and more I'm calling them fractions greater than 1 because that's exactly what they are. These fractions come between, or these numbers come between the whole numbers. So we could have 3/2, which is 1 and 1/2. We could have 9/4, which would be 2 and 1/4. So those are improper fractions. So today's lesson, we're really going to focus on multiplying improper fractions, or fractions greater than 1, by proper fractions. Now, in multiplication, we know that one of the properties of multiplication is the commutative property, and that simply means that we can reverse the factors or switch the factors around, and we're still going to get the same product. Well, the same holds true in multiplying fractions. You can switch the orders or switch the order of the fractions or the factors, and you're still going to get the same product. And sometimes that comes in it's kind of helpful when we're multiplying by improper fractions. For example, this problem says 6/5 times 3/4. Well, in my mind, it's easier to think of taking 3/4 of 6/5. So I'm just going to switch those two fractions around, and we're going to get the same product. So I want you to see what this looks like when we're multiplying an improper fraction by a proper fraction. And so to start, I would want to model 6/5. And so here's my whole, and I'm going to divide it into fifths. So here's 1/5, 2/5, 3/5, 4/5, 5/5. And then we need another whole because we need one more fifth to make 6/5. Okay, so we know we have a fraction greater than 1 and 1/5 to be exact, but we're going to call it 6/5. And now we're going to take 3/4 of that. So I'm going to divide those fifths into fourths. So here's 1/4, 2/4, 3/4, 4/4, and I have to do the same thing on the other whole. And now I'm going to look at where those parts intersect. And so I shaded in orange the 6/5, or they were shaded in orange. And now if we shade in where they intersect, like here's 1/4 where they intersect, 2/4, 3/4. So it's 3/4 of 6/5. Okay, so now we have the intersecting parts of taking 3/4 of 6/5. Now, when we divided the fifths into fourths, we're now looking at 20ths. That's the parts that we're looking at, right? There's 1, 2, 3, 4, 5 by a 1, 2, 3, 4. So a 5 by 4 gives us 20ths. So how many 20ths did we shade in? Well, let's do a little blue check to mark those. We did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. So 18/20ths were shaded in where those two intersected, where we had 3/4 of 6/5. And so you can see right here, 18/20ths can be simplified, right? We can reduce that to 9/10. And so we can say 6/5 and 3/4, the product is 9/10. Now, if we're not going to draw a model to find the product, you can just simply multiply, right? We know that when we multiply fractions, we multiply the numerators, we multiply the denominators, and then we simplify. We don't need to find common denominators when multiplying fractions. We only use common denominators when we add or subtract fractions. Okay, so 6/5 times 3/4. We can do a little cross cancellation. So if we divide the numerator of 6 by 2, we get 3. And we divide the denominator of 4 by 2, and we get 2. And so then we can multiply. 3 times 3 is 9. And 5 times 2 is 10. And so, just like our model showed, 6/5 times 3/4 is 9/10. Let's look at this next problem. 1/3 times 7/5, or 1/3 of 7/5. Okay, so the first thing I want to do, if I'm going to use a model for this, is I want to make my whole and divide it into 5 equal parts. And sorry, this is not the most exact drawing, but we'll get started. Okay, so we have 5 equal parts. There's 1/5, 2/5, 3/5, 4/5, 5/5. And we know this is a fraction greater than 1, or an improper fraction. So we need to have 2 wholes, and we'll need to use 6/5, 7/5. So those will represent the 7/5. So here's 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, and 7/5. So really, the mixed number would be 1 and 2/5. You can kind of see that pretty easily right now, can't you? Okay, so we have 7/5, and now we want to take 1/3 of 7/5. So let's divide those fifths into 3 equal parts. Okay, and now we're going to we're going to shade in 1/3, where 1/3 intersects with 7/5. So here, let's shade in this 1/3, just where it intersects. Well, I guess we could shade in the whole, but the part we're going to count is where it intersects. So here was 1/3, here would be 2/3, 3/3. So we were looking at 1/3 of 7/5. So when we divided our fifths into 3 equal parts, we are now looking at 15ths, those smaller pieces. So here's 1/15, 2/15, 3/15, 4/15, 5/15, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 15ths, which now makes up the whole. And so we shaded in how many 15ths when we took 1/3 of 7/5. Well, here's 1, 2, 3, 4, 5, 6, 7. We would have 7/15ths when we multiply 1/3 times 7/5. Okay, so there's the model that shows you that. Now you can just multiply using the standard algorithm of multiplying fractions, and multiply numerator times numerator, which is 7, and denominator times denominator, which is 15, and we get 7/15ths. Okay, so the directions here say multiply, express the product as a whole number or a mixed number in simplest form. Okay, so we know we're multiplying, and we know the word express means to show. So we're going to show the product which is the answer to a multiplication problem, we're either going to show it as a whole number or a mixed number in simplest form. Okay, so for these problems, we're just going to use the algorithm. We're not going to draw a model, but if that's helpful to you, you can always draw a model. So when we're multiplying 3/7 times 14/5, the first thing we can do is cross cancel. So why don't you, in your mind, kind of look to see what can we cross cancel? Okay, hopefully you said 7 and 14, because 7 divided by 7 is 1, and 14 divided by 7 is 2. And now we can multiply. So numerator times numerator is 6. Denominator times denominator is 5. So we end up with the improper fraction of 6/5. This number is a fraction that's greater than 1. So let's turn this into a mixed number by dividing. So 6 divided by 5. 5 goes into 6 once. Subtract, I get 1 left over. So the leftover part becomes my numerator, and my divisor becomes my denominator. So the mixed number in simplest form is 1 and 1/5. Why don't you look at number 4, solve it, and then check back to see if your thinking matches mine. Okay, 5/9 times 24/7. Hopefully you did some cross canceling, because 9 divided by 3 is 3, and 24 divided by 3 is 8. And if we do that first, then we can multiply. 5 times 8 is 40, and 3 times 7 is 21. So we get 40 over 21. Now, this is a fraction, obviously, that's greater than 1, because the numerator is greater than the denominator. So we're going to divide 40 divided by 21. We know that 21 can go into 40 only once. So we have a remainder of 19. So 1 and 19 over 21. Let's look at a couple more. Again, it says multiply, express the product as a whole number or a mixed number in simplest form. Okay, why don't you try these two, pause the video, and then check back in to see if your thinking matches mine. All right, so looking at number 1, if we cross cancel, excuse my whining dog. If we cross cancel, we know that 11 divided by 11 is 1, 22 divided by 11 is 2, and 3 divided by 3 is 1, and 6 divided by 3 is 2. And so we multiply. 2 times 1 is 2. 2 times 1 is 2. So we end up with 2 over 2, which is equal to 1 whole. So it's not even a mixed number. It's a whole number, isn't it? Okay, looking at number 2. Hopefully you cross canceled. 5 divided by 5 is, not 5, is 1. And 15 divided by 5 is 3. And then cross canceling 4 and 6. 4 divided by 2 is 2, and 6 divided by 2 is 3. And so 3 times 2 is 6, and 3 times 1 is 3. We get 6/3, which is a fraction greater than 1. So 6 divided by 3, 3 goes into 6 twice with nothing left over. So it is equal to, oops, the whole number 2. So just to recap, in this lesson you learned that proper fractions are fractions where the numerator is less than the denominator, and these fractions occur between 0 and 1 on the number line. And we learned that fractions where the numerator is greater than the denominator, these are called improper fractions, or fractions greater than 1, and these numbers occur between the whole numbers on the number line. We looked at what multiplying improper fractions by a proper fraction looks like using a model. And we looked at what it looks like just using the standard algorithm.